Hi, everyone. My name is Eric Betzig, and I'm here today to interview my best friend and tennis partner, Harald Hess, microscopist extraordinaire. And Harold is going to tell us all about his life. Harald Hess, this is your life. So we'll get started. Before we start, though, we have something we'd like to celebrate. So tomorrow, or for us, but by the time you hear this thing, it will be announced that Harold and I are getting inducted into the National Inventors Hall of Fame. And so we are going to start this interview with a toast. Now, Harold and I have been working together for 30 plus years, and one of the staples of our time together is to always share a Diet Coke. So, Harold, you can.
Okay, we've got to open
We're
the
going to
thing.
open this up. Let me pour into your glass. Go into your screen there.
It's into my screen.
Yes, there you go. All right.
Thank you. Thank you.
Now I'm only filling this halfway because I have a surprise for Harold. Because Harold is really German in his heart, and his parents are German. For super special occasions, we don't have Diet Coke, we have Spezi. So, got to mix the orange with the Coke.
50-50.
50-50. Exactly. 49-51 won't do it. Cheers, Harold.
Cheers.
Congratulations.
Congratulations,
Happy
Eric.
to share with you our induction.
It's a pleasure. It's been a long road.
Mm-hmm. And Harold brought another prop. Here we go.
Ready?
There. Okay. Good.
The whistle.
Oh, well. Yeah. Enough silliness. Let's get on with the story. Okay. So how did we get to the National Inventors Hall of Fame and all the stuff we've done? Well, it's been an unconventional path, to say the least. So, Harold, where were you born first?
Oh gosh, in the Midwest. Basically a little town. Grew up in a little town in Midwest. Born in Missouri.
Look at the screen.
Yeah, sorry. Born in the Midwest. Grew up in a little town called Payne, Illinois. There's only population of 6,000. And I think that environment has sort of been a very unique, experience for me.
So how'd you go from cornfields to an interest in science?
Oh gosh, yeah. I think that started for me very early. I think for many people it sort of starts in high school or college, but I was interested in that maybe in 5th grade, started wondering about the vastness of the universe or what's the smallest thing in the world, atoms and the like. And that gradually led me step by step to really focus in on small things, particular atoms, electrons, protons. And a bit later, that evolved into opportunities to sort of explore instruments that probe those limits, in high school, particularly when science fairs came along.
So did you have an engineering bent even before you were working on science fair projects at all? I mean, were you hands-on in things?
I think I always loved, building model airplanes, model boats, early on, maybe a Erector set and things like that.
Mm-hmm.
And yeah, so it's always been a very, sort of very continuous inclination. And I think once sort of the context or possibility of science fairs came along, it just sort of really opened up, the kinds of things that one could sort of go and do.
So what did you do for the science fairs?
Oh gosh, so it started out initially, can I see electrons? And at the time, cloud chambers were an easy way to do it, and basically got, pots, dry ice from a nearby truck stop, alcohol, from my dad's office. It's rubbing alcohol, not the other kind. And, velvet, and just cut up, pots, put them together in a different way, put in the alcohol and the dry ice, and Yeah, and it was amazing. You could actually see as a, as a seventh grader, these little individual tracks of particles.
Mhm.
Yeah, Edmonds was sort of
Right.
a great go-to place at the time for various things and inspiration.
A lot of modern optics people might think of Edmunds as an optics company, but back then they sold more of a hobbyist kind of thing where they sold all sorts of little science widgetry, right?
Oh, yes, yeah. It was amazing. It was just I had a lot of fun going through catalogs and just seeing, you could get a little bag of uranium or other things like that just to explore.
Okay.
And yeah, and then later on, I guess eighth grade, there was just a progression. I read about scintillation counters and I thought, oh gosh, let's get into scintillation counters and got a photomultiplier too, but it sort of got stuck there, because I didn't know any electronics, but still all the rest of it.
How did you snag a photomultiplier too?
Oh, well, there I sort of read up on it and then had my dad call up the company and buy one for me. So I was probably the one kid
You have this in your
in the
Christmas
middle.
stocking or something?
Yeah, it was actually my father was a doctor at the time, so he had these medical laboratory supply catalogs with glass tubing and other things like that. So all of these things just sort of provided, okay, here's a big set of toys or things that one can sort of think about or context to sort of play with.
Mhm. And then where did you go from there?
Oh, well, that was just sort of leading up to a grand project. I was reading about, particle physics, and I really wanted to sort of get like, okay, what are the fundamental building blocks of the universe? And then that sort of led into particle accelerators. I had grand dreams of making a storage ring and you know, colliding the beams, but I never quite got
You're
that
going to do the
far.
LHC by yourself and paint a
Right. But anyway, there were good articles which told how to make one, a Van de Graaff particle accelerator. And here's a picture even of me, in ninth grade, having put that together and, got into glass blowing. So, to measure vacuum, we'd have this, it got broken, but this is like a Magloy gauge. You put mercury in it, rotate it, measure pressures, check for leaks. Got my own mercury diffusion pump and worked hard on fighting leaks, which I continued into my later careers too. It was sort of that became comfortable with all these the challenges of a physicist.
So for the nerds in the audience, what pressures did you achieve in your particle accelerator?
I achieved low enough pressure to actually get a beam for a second
Mhm.
before it blew up.
But you had no way of measuring how many
And
torr or
in order to get a beam, you probably have to be down around 10 to the minus 5 torr.
wow, damn good.
So, and that was done with the two refrigerator compressors, one following the other. You had to open up, remove the check valves,
Uh-huh.
and it had to be a rotary type. Add the mercury diffusion pump, Model T discharge coils to measure pressure too. So actually growing up in a little town really, I think was a big important training of just being resourceful.
Mhm.
You actually really have a lot at your fingertips,
Mhm.
and you can go to the local plumber, other places like that to make things happen.
Mhm.
So it just gave a sense or built a sense of confidence and freedom that one can just
Mhm.
sort of go forward on things.
So did you get much notoriety for building a particle accelerator? And
I was just a little bit the oddball out, and I was comfortable with that.
uh-huh.
Yeah, we had a lot of fun with my Van de Graaff generator. We'd sort of trap a person inside a room, put the Van de Graaff onto the door, ramp it up.
Mhm.
You get sparks about this long coming off of that thing.
Cool. Yeah. So you were the mad scientist
Oh,
at the high
yeah, yeah,
school.
yeah, exactly.
Okay.
Definitely,
How
definitely.
big was your high school?
Oh gosh, I'd say maybe about in each class, maybe about six, yeah, maybe 50 people
Mhm.
in that
Yeah.
range.
Yeah.
It was a fair size.
Yeah.
Got into tennis at that point too. That was my
Okay.
first little place.
Yeah. Cool. And so when you finally got to the end, how did you decide what you wanted to do for college and where to go?
Ooh, okay, that was tough. And we grew up, and this little town was close to Champaign-Urbana, which was a University of Illinois there, which was a very good engineering school. And then my mom pushed me, okay, let's apply to some other places because I was a little uncomfortable making a choice to go into engineering right away. So I applied to University of Chicago, and lo and behold, they accepted me. And that's a little bit more liberal arts. You have a chance to explore other things, economics, or go through the Common Core, because I didn't want to commit directly to one narrow path that early. I really wanted to just explore a little bit, and I think that was a good choice in the end.
So did that exploration lead to anything other than just a deep dive into physics in the end?
I did follow a little bit along on the on the economic side. I mean, University of Chicago is well known for its economics school. I mean, it's another case where, as a physicist, you like to be a model builder, and economics was also a chance where you try to model things. So I had a good time in that until, one of the professors was less interested in model building and writing long essays, which I hated. So, that sort of quietly put an end to the future in that direction.
And did you have opportunities then for research while you were in undergrad?
Yeah, I was actually pretty shy and didn't really start research right away, but was actually encouraged. Let's approach some professors. And one day there's actually a colloquium, and I attended that. And Albert Crew was showing some pictures, the very first pictures of individual atoms taken with an electron microscope. And he actually made little movies that, by imaging, they move around, which is fundamental to a lot of, issues and limitations today.
I'm going to pause the thing here for just a second.
Okay.
So when you get to the points where we're going to show pictures, remember to pause for a few seconds.
A few seconds.
Right.
Okay.
So, we've already skipped a few of those, but
okay.
Let's start the crew thing again, but this time, once you mention it, we'll have a pause right there.
Okay.
All right. So did you have any opportunities for doing research while you were there?
Yeah, yes, I did. I was encouraged to explore research opportunities. I was a little bit shy, but sort of followed the instructions. And just before that, I had seen a colloquium by Albert Crew, and he showed pictures of individual atoms taken by an electron microscope. So this was, a first at that time. And I was really impressed. It was not just pictures of them, but how they would actually jump and move around. And so I decided, gosh, this is something I'd like to follow. And at that point, I joined Elmar Zeitler, who was an electron microscopist. And he had a laboratory where he was developing a large 1 million volt scanning electron microscope. It was double the voltage of my Van de Graaff generator. And it was a fun project to really build this thing from ground up. And the dream of that was eventually to use it for biology. And so we learned electronics, a number of things. So it was a great experience just to go through all of that.
And you worked there over the summers? Were you able to work during the school year? And what years were you working
it was
for Zeitler?
Yeah, it was I guess some summers, a little bit during the school year too, so I'll get a little bit extra, cash for supporting things. And but I think for me, it was like a big introduction into into the field.
So did you have any mentors there, postdocs, grad students, Zeitler himself?
I think the big thing is for me was people giving me opportunities to sort of work in the laboratories, and I think that was a remarkable thing from Zeitler himself. Later on, met other people. James Cronin, who was from Princeton, and he taught courses in solid state physics. It was actually new to him since he was a particle physicist, but I just liked his directness, his engagement of it, enthusiasm.
Mhm.
And so I just really was able to continue my little gravitation toward the, experimental side of physics at that time.
And so you worked your way through Chicago and you seemed to find your first love with microscopy a bit at that time. So how did you decide what to do next?
Okay, yeah. So next, I was a little bit torn on what kind of directions to go into. There's just so many opportunities. I was thinking about plasma physics. Princeton was a good plasma physics place. I was still thinking about particle physics. But I decided, well, let's look at all these possibilities, and of course, applied to a number of schools. And again, I'm sort of lucky again by people giving opportunities. So James Cronin sort of got me into Princeton, wrote a very enthusiastic letter, and so I thought, okay, let's explore real particle physics for a while. Plus, I could sort of explore the Princeton campus too. So switched over into graduate school, went out to Princeton, got flown back to Chicago to Fermilab, and spent sort of a few months there going through the particle physics world. And it was all exciting, but at the same time, these are huge projects. And I just sort of gravitated back to let's get to smaller individual scale projects where you really have the experiment on the tabletop, you own it.
Right. Ownership, control.
Yes. And then went into low temperature physics. So I liked extremes. So the dream of going to the lowest temperature with dilution refrigerators was sort of very enticing at the time.
So I understand that this was a big thing at the time, right? With super fluids and that sort of thing. But it seems like in some ways it's still a pretty big shift from the sort of particle and electron thing. Was that a difficult transition to make, or was that not difficult in terms of actually being able to do it, but difficult emotionally to make that change?
I think there were bigger changes later, but this particular change I think was pretty smooth. At that point, you're not too deeply invested into one particular project. And I always felt like, okay, I really want to explore the breadth of all of the different things out there. And so the transition into low temperature was actually very, very smooth. Worked with Keith Seconda at Princeton for that. And there was a lot of different technologies came into that, microwaves and low temperatures and things like that. So
what was the basis and title of your thesis?
Oh gosh, I'm not sure I can remember the title of my thesis directly. Do you remember the title of your thesis?
Non-destructive optical imaging of surfaces at 50 nanometer resolution.
Oh gosh, okay. Yeah. Okay, yeah. So for me, it'll probably be something observing two level systems in dipolar alkali halides at low temperatures.
Okay.
At the time, there was an interest like what are the states which form low temperature glassy things, and here was a chance to sort of probe them, the individual energy levels, and get their signature on a little microwave device at low temperatures.
So did this involve a dilution fridge at that?
Oh, definitely, yeah.
So how cold were you getting?
This one we're just maybe getting down to about 30 millikelvin. And it was enough to begin to sort of populate two level states into the lower level of the two levels and begin to see increased absorption associated with that.
Cool. Okay. All right. So now we're done with graduate school. So was there any doubt that you were going to go again towards a more academic path at that point, or were you certain that, okay, postdoc is just, it's blinders on, that's the next thing?
No, I was exploring broadly. I was thinking about industry, looking at IBM was sort of like very big place to sort of go with the future career, and interviewed there in a few places.
What was wrong with Bell Labs?
It was too intimidating.
Just down the road.
It was too intimidating.
Okay. But IBM was not.
IBM, this was more of an engineering kind of application. And I thought, okay, let's just sort of look a little bit more broadly. I didn't really know what to do. Bell Labs, going into Bell Labs, you really have to have a sense of, okay, drive. I
an
want to know
idea.
an idea, yeah. And so I was just looking around for different postdocs, and um, and I applied to one postdoc at MIT with Tom Graytech, Dan Klepner there too. And to me, they had a challenge where they wanted to see Bose-Einstein condensation. And to me, in a very simple mind, where you think of the old Greeks, you have earth, air, water, and fire. And the Bose-Einstein condensate was like the new
Like
fifth
state
element, the
yeah.
new fifth state. And so I thought, well, this is the opportunity of a millennia, and and just got into it full force.
Okay.
And I think that was a natural transition too.
And uh, there was one particular conceptual innovation you made there. Can you tell us about that and how you came up with this idea, which is basically the missing link to make Bose-Einstein condensation?
Okay. Yeah, I'll tell you the postdoc was like a real growth phase for me, and a very much of an up and down emotionally. So yeah, in this slide, you can see there's this phase space of where the Bose condensate is in density and temperature. And we were out here in a gaseous phase. And so initially we built something to go up in pressure and try to get there. It exploded, didn't work. And then I felt my postdoc career is ruined. Physics is over. And then going back home in a big, deep depression, just started thinking, oh gosh, what else can do? And suddenly came up with a little idea. Oh, maybe one can evaporate these things in a magnetic bottle, where a lot of the standard mechanisms that destroy it go away. And so then I got excited again.
So I'm always curious about where these sparks of ideas come from. Were were you like driving at the time, or do you remember the exact instant when evaporative cooling came into your consciousness?
Yeah, I think I went home and I was probably eating my dinner, a yogurt, and just ruminating about the whole thing, and just thinking about the physics of the different states and their limitations. And then I'd say just sort of popped in.
Yeah, popped in.
And
that's usually the way it is.
yeah, it was just there. And I just remember I couldn't sleep that night. I was thinking, I know how to get the lowest temperatures in the universe now.
Yeah.
And got a little bit full of myself at the time too.
Yeah,
but
well,
it was cool.
Yeah.
And maybe as a little post note to that, later on, I just sort of kept it to myself. I thought, okay, this is mine.
Right, that's your intellectual.
It's my intellectual property. But then at some point, let go. Mentioned it to a few other people. Tom Graytech's father-in-law happened to be John Bardeen, a person who has 2 Nobel Prizes.
Yeah.
And he said, well, why don't you explain your little idea to him? And then he sort of listened, very polite man, listened to it and said, good. Now, have you thought, how do you produce the high energy atoms? How quickly can you produce the high energy atoms for the evaporation? And that was a calculation or thing which I did not think about, and very fundamental. It involves cross sections and how quickly can you form it. And then you look at the whole thing again, and the idea just collapsed again. Back into depression. And then, of course, you think, okay, maybe there are other ways to sneak around it. You do adiabatic cooling with compression, and then fixed up the idea. And then, okay.
So Bardeen's question had a real impact then.
It did. It was very, very insightful. Very interesting. Few other understanding the cross sections for relaxation, which others pointed out too, was so it was good to open up again and share the idea a little bit. And So I worked hard on it. The slide here shows the apparatus too, which I put together, but could only go so far. And and that was sort of the end of it.
So that becomes then the other fundamental question, other than the creativity question, is when to fold your cards, right? Because
Right.
I imagine you were fairly well in love with your experiment at that point.
Oh, totally.
So how do you decide to have a divorce?
Okay. Well, so at this point, really felt, yeah, of course, as you mentioned, this was mine. And then there was a transition. Okay, do I want to go to the next job? Didn't really feel that there's the funding, with the funding agencies to make a second laboratory going along in this direction. And so then I just looked around, and there was Bell Labs was there. So that was a place which I thought, okay, let's take a look at that. But that was the beginnings of a very, very difficult transition. And so Bell Labs, as you know, coming in on an interview, they ask you, well, what's your idea? And
what would you do if we gave you an empty room?
Exactly. And money as you need it.
Yes.
And so here I was a little bit at a loss. And so trying to sort of build a little bit on my background, I said, oh, Bell Labs doesn't care about hydrogen atoms. They do electronics there. They care about electrons. So, okay, how about evaporative cooling of electrons?
But at the same time, let me interject here, because at the same time, in that era, the physical research division was still doing some very, very fundamental physics.
They were.
Did it occur to you to pitch trying to do Bose-Einstein condensation with evaporative cooling at Bell, or did you feel like it was too much of a competition with your old group?
I don't think I really considered it that seriously there. I sort of felt, okay, I have to, maybe it is competition with the old group, and I just felt like it wasn't quite appropriate,
Okay.
To the more basic directions of where Bell Labs was
So you
going.
were more motivated by the thought that you didn't think it would fit in as well with Bell, even though you still loved the work and loved the idea.
Right, exactly.
Okay, got it. All right. So then what did you pitch for your empty room?
Oh, so the empty room was just thinking, okay, something about maybe I can pull electrons out of semiconductors and cool them below the lattice temperature, make weird electronic states that way. Sort of bootstrapping on that. And then you have to get into other limitations. How quickly do electrons couple to solids? You have to make them decouple at low temperatures. And so that was the pitch. And then, of course, the really tough day comes when you actually have to then move to Bell Labs.
Mm-hmm.
And you're faced with an empty room,
mm-hmm.
and all these brilliant people, with big names and reputations walking around you.
Mm-hmm.
And it was really intimidating.
That's the word for it.
And actually, at the time, my boss who hired me, again, just somebody who put trust in me, Horst Sturmer, recommended that don't jump into things too quickly. Take about 6 months off, look around, talk to other people, and just let your thoughts settle in a little bit, as opposed to, trying to hit the ground running on the next project. And I think that was really, really wise. And I think there's often just too little opportunity for people just to step back and put the momentum that they have, stop it, and then rethink where to go. So that was valuable. And in that time, I sort of shifted away from direct evaporative cooling of electrons to something which was popular at the time, which was to look at scanning tunneling microscopes, but at low temperatures. I felt I could build the things. Everybody built scanning microscopes right back then. That was just that was in the
air.
In the air, yeah. Superconductors were also in the air at the time too. And so then I headed down, instead of evaporating electrons out of semiconductors, I was just dropping them out of this little needle into superconductors. And I got lucky and then built this cryostat. You can see it in the picture here. And, beside it, you can see pictures of individual vortices. I mean, I sort of had a nice run at Bell Labs of trying to see individual things like individual vortices and later on individual electrons. And there's a little surprise to the audience. I still have that cryostat right here. I'm going to walk off screen, bring it on screen real quick. And here it is. Ta-da. Okay, I'm going to walk right across both sides.
Harold is the ultimate pack rat. He never throws anything away.
Okay.
All right.
So yeah, that was a little bit the center of my life, at Bell Labs.
So when did you make the transition at Bell from feeling that you're just a lowly bug not worthy of being there to actually feeling like you belonged?
Yeah, I think that probably came with the first success of that experiment, seeing these individual vortices.
And that was how long in?
That was maybe about 2 to 3 years after starting.
Yeah.
And it was, I don't know, and that was actually, so it was very, very satisfying to see, okay, all that work, by golly, really paid off. And, I can, transition from being in total fear to being okay. I'm not sure about one of the gang, but at least not being totally uncomfortable.
Yeah.
I'm always uncomfortable.
Yeah. Okay, good. Yeah, so I guess then what did you do ultimately when some weird dude came in from Cornell University?
Oh gosh,
who wanted to do scan probe microscopy too.
Yeah, I remember when that
did you think that dude was just too weird to hire? Did you tell Horst stay away from this guy, he's full of shit? Or
I thought, okay, I'm doing electrons, he wants to do photons, it sort of fits. Photons, maybe I think electrons are cooler than photons, but cool. So, we need to diversify into the different kinds of scan probes. And I thought, that's this, it sort of makes a good fit.
Yeah.
And I was very much, in favor of it.
Yeah.
And then,
well, let me just interject for a second about, this is obviously me. And when I first met Harold and, look, I mean, our relationship is platonic, but from a scientific and friendship sense, for me, it was love at first sight. Okay. I mean, he was really, really, real. Our mental processes are just so in tune. We're just different enough to make each other better, but same enough that we can do tennis, everything, Wendy's, eating Wendy's for lunch, whatever. Yeah, I had that same feeling of being I didn't belong. And then Harold made me feel belong at Bell. But anyway, enough about me. Back to you and back to eventually. So tell them a little bit about like what we would do before we started actually working on our experiment together.
Okay. Yeah, I think, and we sort of had a lot of common interest in their both scan probe microscopes, same issues of software and hardware. How do you make it stable? And so we had a lot of lunches or dinners. We both love to work long hours, and
we love to compete.
And love to compete. Yeah. In intellectually and trying to start. Well, that became worse the more we worked together.
Yes, absolutely.
But
who can come up with the idea for shit?
Yeah, right. Oh, that's neat, right? but yeah, there was and I think we really built on each other, you
Yeah.
know, so that we wouldn't stagnate off in one corner or the other
Yeah.
in the other direction.
Yeah.
And yeah, I think at some point, you know, we sort of decided, well, you know, what you were doing and you were doing this. I don't know, do you remember this?
I sadly do. Still have nightmares.
Here.
Anyway, you can't see it in here, but there's these, because Harold never throws anything away, there's some little optical fibers that have been pulled down to sub-wavelength size with a little hole. And that was near field microscopy as a early super resolution technique, which is what I pitched when I came in. And, you know, I mean, Harold and I mean, I don't think he's sufficiently told how close this relationship was, but we would each come into the lab around 4:30 in the morning, work until sunrise, go to play tennis, work all day, go to the same Chinese restaurant for dinner together at night, then go back into the lab and work until sometime in the evening and wash and repeat 7 days a week. And it was great.
Yeah.
Except for a time that we'll discuss later. It may have been the best time of my life. And so, but ultimately it led to actually us working together on this project, which we can discuss.
Yeah, so the cryostat, which I was doing all the other instruments on, Eric and I were talking and thought, oh, wouldn't it be cool to look at near field super resolution at low temperatures? And the context there was to look at semiconductors. You know, some of them glow, and can we sort of look at the glow? Because if you put them between quantum wells, they have a broader spectrum, which seems to go with, are they a little thicker one by one layer or a little thinner? And together with one other colleague, who's now also here at Janelia, Jim Harris, we sort of quickly formed a group. That was the amazing thing at Bell Labs. You can just sort of spontaneously form groups, bringing expertise from 3 different directions just to focus in on, you know, on one experiment. Actually 4 directions, you know, people would be supplying the material too. And that led to a, you know, really great collaboration. And you can see in this slide, we looked at this material with Eric's tips on the cryostat that I just brought through. And we looked at the spectrum. Another person provided lasers, Tim did. And I still have the spectrometer here too. So I
And
haven't
we
thrown
have
that
the
one.
best materials in the world
Yeah,
as
yeah.
well, Bell Labs to study.
And then we looked at it, and I think this was a, you know, a very important experiment because we looked at it, and to our surprise, instead of seeing a big smushy spectrum, you see lots of sharp little peaks. And this is something that each of the little peaks that you see there are individual fluorescent centers or luminescent centers. And yeah, so that worked out well. We competed, you know, we had a horrible time writing the
Oh
paper.
God, that was horrible.
I know.
I think the palm paper was easier for us to write than that paper.
Yes, yeah,
Yeah.
definitely. Yeah, we competed on the words.
Yeah,
He had these fancy words like Penelope or
Whatever.
plethora.
Panoply.
What?
Not Penelope. Anyway, yes.
Whatever. I knew I didn't like that word.
Too flowery for you.
Yeah.
Yes, I get it. Yeah. All right.
And yeah, so I guess, oh gosh, what happened after that? I mean, then you left
Yes.
shortly after that.
Yeah.
And made one final little comment about it, and you're off. I sort of hung around Bell Labs a little longer. Wanted to see individual electrons. I thought, you know, seeing molecules like you did, well, like, okay, those are bigger things, not as interesting. I can see little individual electrons. Did that, another paper, and then, you know, then
You had magnetic Hall probe and
magnetic Hall probe. Yeah, those vortices again. And
so why'd you leave?
yeah, at the time, there was a I mean, you were experiencing that too at Bell Labs, a little change in both internal growth. We're more mature at this point, or have completed that mission of doing new research on our own. And at the same time, the direction, the appreciation for basic research was changing, and there's more an emphasis on trying to do things which are relevant for the bigger economy. I always felt like, well, at Bell Labs, we were privileged, to be given it to contribute. But what's really needed is get it into the marketplace, really add to the technology. And at the time, semiconductors and hard disk drives, and all these things were just exploding. So instead of looking at one tiny little thing at the nanometer scale, to me, I sort of thought, well, what's really needed is seeing not just one tiny little thing, but millions or billions, and measuring in a completely different context. And so at that point, and this was, again, like a super painful part, I sort of packed up my lab and never did another experiment with that dilution refrigerator again. And it was painful, and went off into a little startup called Phase Metrics.
Why did you go that route? I mean, you could have, you were famous enough that you could have gone to a university. You could have done, gone to IBM or wherever. Why a crummy little startup?
Yeah, and that's absolutely right. I did have other opportunities. I mean, universities would have been a natural place, but I sort of felt like I'd sort of exhausted what one can do with a scanned microscopy.
Mm-hmm.
And I was just really haunted by this question of relevance.
Yeah.
Where's this going to go in the end? And I thought relevance is in these other industries. So best way to learn about it is just immerse yourself into it. So it was a painful, wrenching decision. On the one hand, you want to stay where you're secure. On the other hand, you want to sort of learn new things and move forward. And I took the more painful path. Mm-hmm. Went into a little company. The day I walked in, they said, "Oh gosh, they hired a new person. We just laid off 100 people yesterday." And
welcome to California.
Yeah, yeah. And me being stubborn, I didn't even notice it or read the tea leaves, and said, "Okay, I'm ready to work."
And so what did you do there?
Okay, so this is a company which was trying to make test and measurement equipment for the hard disk drive industry. And they had these instruments called certifiers, which make sure their disks are good and don't have holes. So that means like nanometer scanning at gigahertz speeds. And they developed some ideas like how can you use the fiber optics, which I learned about at Bell Labs, apply it over into this. And they had interferometry requirements, which were sort of cool, multi-phase interferometry, which I got into. And I thought, gosh, this is sort of a solution for a lot of different things. I was a little bit blinded by my own enthusiasm for going this route. And I just sort of worked on the little instrument that you can see here on this slide, hoping that, okay, this will save the company. Worked hard on it, maybe. And while this little division was shrinking and shrinking, one day I was told also, like, okay, you're one of the people who's leaving. And so then I had to basically stop that. I had one very valuable lesson learned from that was listen to the customer. And this is something that in a more academic setting like Bell Labs, you think, oh, the customer is writing the paper. No, they're real people out there. And turned out all the customers were going bankrupt. So why was I investing in all of this?
So the multi-phase interferometer for fly height testing that you developed, was it the wrong idea at the wrong time, the right idea at the wrong time, or what do you think? I mean, why didn't it, obviously that's a boom bust cycle there.
Mm-hmm.
Why do you think it never ultimately got adopted?
I think it was maybe the right idea way too late.
too late.
Yeah.
Okay.
Timing is important. It was in a bust cycle.
Mhm.
When bust cycles happen, nobody wants a test. You don't want to hear bad results about your
Yeah.
product. You just
Right.
want to have good results. So you just turn off the test machine and don't buy
I
any
know
more.
that from my own history tells me exactly the same
You've been through the
thing.
same thing, right?
You're just compromising yield, and they don't want to hear that.
They don't want to hear that at all. Right, right. But anyway, this little tough experience
Yeah.
really opened up my eyes to that.
Yeah.
And sort of shaded my view of whatever comes next. I was fortunate later on, a friend who was also at Cornell, colleague of Eric earlier on, David Adler, other people at a company called KLA-Tencor, which eventually bought this hard disk drive company, took me in, put me under a little DARPA contract. And I had a chance to see all the high-end, high-throughput microscopes which could applied to the semiconductor industry, reading hard disk drives, and how it was a little bit of a different world, one that you don't really hear about outside of that industry much. But I think it sort of did teach me these whole ideas of very high throughput data acquisition. And but there were a lot of other factors that eventually we got a nice contract to do it, but things weren't quite going the way which I'd like. And then
And was that for technical reasons or for management reasons?
I think it's very much for management reasons. So, a ton of money came in to support that project, and then they assigned some manager for me, and and I couldn't lie about the physics, and I just felt a little bit under strain. And then you started calling me up too.
The conscience in your ear.
Yeah, yeah.
Yeah. So why did you start listening to me?
I was basically at the point getting a little bit more frustrated and a little disillusioned. I really missed the research side a bit too. And it was just going in just directions which were just not true to the physics. And I thought I had a choice, either move from one location, San Diego up to Silicon Valley, or change fields. And then I probably again did this thing of choosing the harder path, which was give up what was at that point a somewhat secure job, and just say, okay, let's
jump off the cliff and build your wings on the way down.
Right, yeah. And there's a slide for that.
But again, the goal is to try to find the intersection between science and relevance, right?
Exactly. And I think that again, we're really torn on the same kinds of issues. Yeah, because we spent, and you remember
a lot of time in irrelevance and a lot of time in the problems of trying to get good technical solutions adopted in industry.
Right. Yeah. So, well, the rest is sort of canonical story, at least of the.
Now our paths join again, huh?
Join again.
So tell everybody a little bit about, because it wasn't immediate and obvious, right? I mean, I first visited you once or twice while you were at Phase Metrics, but I think most of the time I was pestering you. You were already at KLA.
That's correct.
And so at that time I was thinking more about just reconnecting. So how did we reconnect, and what did we do, and where did it lead?
Yeah, I think we first reconnected through, just trying to make little mutual visits, go to national parks and go hiking, and just discuss the state of research, where the opportunities are. I guess we're both very much white space oriented, where unfilled areas of research that, might provide opportunity. And here's the interesting thing. I guess reflect that you initially incorporated yourself as an LLC called New Millennia Research.
Yes.
And so I emulated that, you know, as new quest research. You know,
Except you had to do NU instead of NEW.
yeah. And yeah, so yeah, I thought, okay, I'll resign, let's drop, and that's cover up the fact that we're both unemployed. I guess we just sort of put a little,
Everybody does that.
yeah.
Right? Somebody running an LLC immediately figure, oh, that's another way of saying you're unemployed.
Right, exactly.
So where did the spark for Palm come from then? How did that happen?
Oh, well, that was again to this little slide of where we hit bottom. It was we in our wanderings connected with someone we knew at the Magnet Lab from Bell Laboratories, who knew or had in his laboratory somebody who was an expert.
A little bit. The head of the National High Magnetic Field Lab was trying to hire you away to go there.
Right.
So that's more the way to put it, right?
Okay.
Yes. And I said, can I tag along?
Yeah. Yeah, well, they had one.
Well, you already did one trip.
Yeah, I had already done one trip, and I thought, oh, there's a biologist here, which was like a new entity, which I've never really seen before. And then I thought, okay, let's tag along. Maybe we talk to this person. Maybe there's something that come out of it. And by golly, that was transformative.
Mm-hmm.
We met him, talked about fluorescent probes.
This guy was Mike Davidson, by the way.
Exactly. Very unusual person, but very, very creative, very brilliant.
Mm-hmm.
And, probably about 5 hours later, we said, that's going to connect with our old ideas.
Yeah.
That we had sort of experienced on the semiconductor near field experiment back from Bell Labs. And you wrote a little paper that sort of pointed out some further possibilities. I thought, that's academic, but this was the missing link.
It was. So basically it's we learned about photoactivated fluorescent proteins from Mike.
Yeah.
And, in the quantum well experiment, we could see those individual points of luminescence, and we could look at them individually because they glowed in different colors, even though they were stacked on top of one another. So now,
yeah,
when you learn photoactivation, you say, well, they could be turned on at different times instead. You go, shit.
Yeah. Yeah. So it was patent writing, a rush. This is, of course,
I remember a nice trip to Sedona, right?
Yes. Patent writing in Sedona.
Writing claims on a bench in Sedona.
Yes. And multiple, rocks too, everywhere.
Yeah.
And then shortly after that, it was, the rush to build a thing. And that's where we met in my living room.
Mm-hmm. And why your living room, and what made it easy to do it there?
Well, I still had my stash of Bell Lab stuff. And we thought, okay, maybe we just pull some of these things together.
Didn't I tell you he never throws anything away? It actually turns out to be useful, believe it or not, although I thought he was nuts.
Yeah. At the time, there were on top of that, there were a lot of other technology companies going bust because it was the bust time. So you could get things for cheap on new places like eBay at the time too. So we got, put together things, got a microscope going. And, this is all very, we were now on the manic side, very high, high pitched.
Yeah.
Eric made the final connection to somebody at NIH, biologist, who was willing to buy a very expensive camera for us. And that's how we ended up in this place.
Yeah, we didn't exactly want to spend $30,000 on an EMCCD ourselves if we didn't have to, which would have kind of doubled our investment. So, yeah.
Yeah. So we ended up in this dark room.
In Jennifer Lippincott-Schwartz's lab at NIH.
Yeah, and you see a Diet Coke on the bench on the right side corner of right over there in the picture too.
Yeah. So some things never change.
Yes.
And how long were we there?
I don't know. We worked in 2005,
yeah.
And then into early 2008, struggled to sort of re-enter.
2006.
2006. Yeah. Thanks.
Yeah.
And then got something out, and then there was this new place you discovered called Genelia Farms.
Yeah.
And we toured it.
Mhm.
Uh,
Yeah, in fact, yeah, I got on the payroll in fall of 2005, and then when we were bringing the microscope out to NIH, since it's just across the river from Genelia, that's when you first visited, right?
yeah, I think so. Yeah.
And I remember Chuck Schenk, you opening up the suitcase and showing the parts of the microscope.
Right, right.
Chuck used to be a bigwig at Bell and then bigwig at Berkeley Lab. And
And then
I think I think Genelia fell in love with Harold as soon as he opened that suitcase.
yeah, I don't know about that. I mean, to be honest, still felt a little bit on the edge.
Yeah.
Yeah, and here's a picture of us again, two people with shell names of who they are. That looking at the housing there. Eric combing his hair, of course, putting his hard hat away.
And of course, we ended up in apartments literally next to one another. So.
Yeah, yeah. So I think the one remarkable thing, it's funny how things just sometimes tie together. I was in the semiconductor industry, and okay, there's like scanning chips, nanometer resolution, and there was a little bit of a general challenge. Okay, let's get a fly brain. So I thought, okay, fly brain, computer chip, what's the difference? Let's just go for it. And yeah, in this particular slide, I had a very naive picture of what I was going to do. I was going to line up about 1,000 flies on a little disc, and just chop them off with a shaving station and then a bunch of microscopes. I presented that, and by golly, they hired me. It was by modern standards, there'd be no way they could get hired with that, but they somehow
Maybe
believe.
it was people, not projects here.
Yeah, I don't know. Definitely, it failed on the
case,
project.
it's people and project, yeah. But yes.
So then we both got in and had a lot of fun for a while.
Going kind of on separate tracks, and then ultimately joining forces yet again. Well, of course, we get to play tennis and eat at Wendy's, and so it was like Bell Labs Mark II, basically, right? So,
yes.
So it was great.
Yeah, and it's similar to Bell Labs Mark II. Sort of a few years ago, we combined forces one more time. For a low temperature aspect together with structured illumination, and maybe Palm, and put together a system. And by golly, it worked.
Yeah. So had a good paper on correlative, right?
Yeah, paper on correlative.
And now today, what are you up to?
Oh gosh, today it's a little bit back into the electrons. And so I always felt like, there was like a new world, with electrons that one can access. Before, electron microscopy has always looked at thin sheets very locally. And with the inspiration of trying to get the full fly brain, you realize there's this whole other world of just looking at massive tissue, but with electron microscope level resolution. And so then just sort of evolved or modified machines like focused ion beam scanning electron microscopes, which were used in industry or semiconductor, and trying to pull them out for biological application. And that's, I think, worked out very well. In a funny way, I think coming back to that field was, maybe a little continuation of the vision from my Chicago days, when Elmer Zeitler had an interest in trying to see biology with an electron microscopy. And yeah, to me, I sometimes think, well, we're all little intermediates in this grand path of science, and each has a little opportunity to be a part of it for a little while.
Sort of like a random walk under some potential or something.
Yeah.
Bouncing forward, but not in a straight line.
And trying to have fun in it all too.
Yeah. But now Harold is basically the king of Genelia. They all depend on Harold. So
I wouldn't go quite that far.
well, I would. So yes, he's a star again. So what about the rest of life? I mean, I've always thought of you as by far the most private person I've ever known. So you shocked me at your at what happened with you.
Oh, yeah.
Uh,
Decided there's more to life than just the science. I've been pretty much exclusively science only. And then decided, okay, let's find someone, get married, and and here's a picture of my son. This is like from a few years ago.
budding microscopist.
Budding microscopist, yeah. And and the world passes on.
Yeah. See where he goes.
Yes.
All right. So wrapping up, we will say how much longer are you going to work at this?
Oh, on these.
Well, how much
Microscope?
longer? Well, these microscopes, and then when do you ever see yourself retired?
Not really.
Mhm.
Well, I just feel so lucky.
So when do we
so
get to the hot
privileged.
tub?
Oh, yes. Yeah, we had a moment when we're in San Diego, when we're on sort of the down. No, we're maybe on the backup
No,
side.
It was always when we were going to the tennis court. There would be
On the tennis court.
two
Yes.
rather large gentlemen, old gentlemen, sitting in the hot tub every morning. We said, someday that's our future.
Yeah,
Right.
exactly. So yeah, we'll try to stay fit as long as possible.
But knowing the hot tub awaits at some point.
Awaits at some point. Yeah. Try to defer that as long as possible. Have as much fun with.
So right now your plan is to full speed ahead, and the hot tub happens when it happens. Is that it?
Basically.
Cool. All right. Well, thank you very much, Harold. It's been a fun ride. I hope we have many more fun years together going forward.
Yeah, it's very much mutual.
Thanks for the peek into the highly private life of Dr. Harald Friedrich Hess. Thank you, everybody.
Thank you.